My name is Andre Henel. I'm working in the KNX Association, and I am responsible there for the system and tools aspect. And within the next 20 till 25 minutes, I will explain you shortly about the KNX IoT third-party interface, especially how to connect from external systems to KNX and what is the outlook for that scope, which is a broadened scope in the Internet of Things. So to discuss about services with KNX and especially how to do that with the KNX IoT third-party interface, which is a major and important part of our KNX IoT development, I have structured this subject into 3 introductional parts and then the IoT basics, especially belonging to the KNX IoT third-party interface. We will speak about semantics. It's an precondition for that. We will speak about the data in KNX, also the workflows, which are very important. And we will also speak on, for sure, the ETS data and especially the data structures on the API, that you are understanding what data you can retrieve and what data you can send over the API, finally to access in KNX system, KNX installation. For this, we will start with the concepts, and the first question we have to answer, why do we need semantics in KNX at all? We will start with 2 simple examples. And what do we need when we would need semantics at all? On the left side, you see here a semantic schema or a shape of an ETS project which is using a building structure and possibly is using for a certain functionality a kitchen. So, assuming you have in your kitchen an hi-fi, a radio, and you want to start this radio or this hi-fi to play a song or something like this by simply telling it to the radio, by using an Alexa, for example. So then at least you have to say, please, Alexa, play my radio or play my hi-fi or my stereo. And Alexa at least should know that you have a stereo in your kitchen. Assume that you have not a stereo in something else rooms. Then it must be clear for the kitchen, okay, it's only the only one what I can play with. But if you have more than one, then you need a distinction between, is it that in the kitchen or is it in the living room? So you need clear defined terms, for example, what is a kitchen and what is a kitchen belonging to. You have to assign this in the ETS project that this stereo, for example, works in the kitchen. And kitchen must be something what Alexa is understanding. So consequently, we need terms, and we are using here a simple example, like kitchen, somehow added to a dictionary which can be understood from several appliances, also in the phase, or especially in the phase when we are speaking about M2M, machine-to-machine communication. That is the example given from the domestic appliance. When we are looking to something else, and thanks to the colleagues from Siemens, where I got the picture from, we see here also when we are looking in the industrial domain, in the building automation domain here, that we have different, or let me call it different phases where how a building is maintained. It starts from the planning, from the architectural perspective. It ends somewhere when a building operator is maintaining the building. And somewhere in between, here represented with KNX reseller and system integrator, also a KNX project is somehow involved in by getting data for the products, by planning something how these products should be used. That's the system integrator, including the reseller, distributing these products to the appliance or to the assembly place where the building will be constructed. Okay, so that means we need also a workflow from data from left to right. And it's more and more important because of the reason that, and that's a subject which comes more and more into account, is that these data needs to be documented in the scope also of building information model, and needs to be available also to maintain between different domains here, so that people accessing data which are not created by themselves but created from the previous, let me call it column here, like a consultant engineer and architect, and we will see such an example. What does it mean in the next picture where we look to KNX, how KNX will do that. We have stripped down that picture a little bit to say, okay, assuming it's a KNX installation, and when you are thinking back on the slide from the last slide, you saw that there somewhere in between in the columns, there was also an installation with the KNX, and we need some pre-processing. So that means a planning where we are creating data on the architectural level, and these data must be somehow get into a planning tool or a configuration tool in that sense, what in this case is the ETS. Here we have the possibility that the ETS can deal with the data created from the architectural level. So we call it pre-processing. So that means we need a data input. Then we are doing the configuration as usually. And then we are exporting the data. So we are exporting the data for two purposes. One was shown in the previous slide to document a communication, to document an installation, for example, with BIM. And the second very important subject is to use them to operate with the data from such an installation. And here we come to the point KNX IoT third-party API, IoT Gateway, the interface. That's also a need to feed the interface with the data from the installation. Okay, that is more close to the KNX subject, what we will discuss next. So summary for that, why we need that? Yeah, we need standardized dictionaries only because, simply because of the subject that between different domains, you need an understanding what terms means. You need machine-to-machine communication to simplify such a communication between different systems. And as you know, KNX is one system, Google is another system. There are a lot of other systems, and they need to interoperate each other because there will be not the overall system which rules everything. So, and you need also to improve the speed on creating, assembling, and bringing to operation such a building. Yeah, and for sure also asking the building to its operational states. Yeah, simply spoken, that's a collection of requirements which we have to fulfill. Not only we, also in the IoT world, systems which will operate within buildings. So, make a short recap to the data in KNX. And as you see here, the data are structured according to three principles. We have manufacturer data on the left side. They represent, we call it the catalog data, or especially the data which you need in advance that you can create an installation. Also on the architectural level, possibly you need these data, at least in the planning phase. For sure, we have data driven from the KNX itself. That's installation or system, it's KNX data on the system model level, so that we have the possibility to say, okay, ETS has clue about what communication is being used, what are individual addresses, and so on. Finally, when you are exporting these data, then you have an export, which is an instance of that very project, what you have done with the ETS here. So, and at the end, this project contains of the KNX installation and manufacture data as well. Okay, good. Today it's XML driven. This format is well known, but we need also in the future to represent different subjects that data from KNX must be able to understand in a different format, especially when you are looking for cross-domain interoperability or cross-domain understanding of these data. So you must be able, let's start from the lowest part here, from the last bullet point here. You must be able to ask the data something. You query data, okay? And the data must be able to understand also from non-KNX experts. And I'm not speaking here to that we are discussing about XML, yes, no. We are discussing about the concepts of an installation of an individual address. Are these concepts known to others? Yeah, and we will see also that some of these concepts needs a change in the terminology when we are looking to APIs. So that is a goal what we have to fulfill, and especially also we need to map them and we need to describe them semantically. Okay, therefore also a different format and different technology to express such data was chosen, and here I'm using the word to have a redirect. That's in so-called ontologies where we are hosting and expressing these data. Okay, why do we do that? Here important when we are looking a little bit to the workflows. That's a more technical picture of that what we have already done or what we have seen in the beginning. post-processing and pre-processing, or the pre-processing is more on the left side here. We have catalogs describing data. These data will be used in ETS to create projects, where you are configuring an installation and you document the installation. Then you need to export them for the purpose of what we have seen before, external representation from data being part of the BIM, or being part, and that's the scope which we are looking forward here more in detail, to be used in a third-party API or an IoT interface. A gateway was it called at the beginning. We need to express this data to a certain amount according to a specific structure, according to a model. The interface itself, when we are looking for the third-party API or the gateway, must be documented in some specific way, able to be used from third-party clients. And here we are on the IoT world, where we having people don't know anything about KNX except the name that this is a system and can do something in the industry and the home and building control domain. That's what they are understanding. Okay, let's scope to two subjects from them. One thing is this documentation of the data which we will export, and the other thing is how this API would look like, which a third-party server and API was providing to clients, and here to developers creating such clients. This would be such a client being created from, somebody is controlling an Alexa, and the Alexa needs to understand what's going on in such a system by an example, using the terms kitchen in accordance with switching on something in the kitchen. Okay. For this, we have to understand, for the bullet point 1 here on the left side, how this is somehow constructed of. Don't be bothered with the complexity of that picture. It's easy to understand. We have an information model, and this information model contains of two, let me call it, 3 major parts. One part is, and that's exemplarily that we are seeing it here on the left side because we get some slides where we will see this in detail. We have to describe locations, a building, according to something which is known in the Internet of Things, or which is known also in BIM, it's so-called IFC. And this is embedded in the system model. And the system model will be describing how KNX is working, what concepts we have, for example, devices as part of equipments, we have installations which we can represent, we have applications, we have points communicating at the end, and we have also the things what we call in KNX an aspect or a function point is communicating with the devices. That's a term which we are using in the system model to express more what in group address is, to not always reuse group address which is not known in the IoT world. For sure, also we have here the tagging model, and the tagging model represents the things which we are using in the semantic dictionary to tag things in a KNX installation with terms from a common dictionary which we will take over from somebody else, or where we have a similar term where we say same as. Okay, let's have a look to the location that we are understanding what's going on, and there we will have a small or a closer look to that. And when you are looking to the location model, you see, for example, here, it is structured according to its dependencies, its possible relations, but it does not mean that we have here a horizontal limit, a horizontal structure of that, for example, a location is on top, there must be a floor underneath, and underneath the floor there might be something else or a space, and underneath the space there is a room. No, this is only a dependencies what ontology-wise classes are there to represent the building structure. And we have not invented this by ourselves. This is related to IFC, which have already done such building structures in the Internet of Things, respectively in the building information model. One thing, so that's the information model. Next thing, the data workflow from A to B, 1 to 2. Yeah, we remember 1 was the information model and the export, and 2 was the server with its API. And when we are looking how this is combined together, we see here on the left side the famous example location model in an ontology representing the building structure of an installation. We see here an example of a building structure part of an ETS project. We see here, and that's surrounded with this ellipse here, the main building. And in the export, we find back a correspondence of that what was in the project here, reflecting the main building. So it looks like a data structure. Okay, it might be also looks like an XML structure, but it isn't, because it follows the format. I remind you on the requirements on that format that it must be exchangeable, less version independent, able to understand from outside, and it must transport semantics. And for this, linked data triples are the preferred technology to make it. At the end, that's all necessary to feed, for that example, data into the API to be consumed from a client using this API. That is number 2 here in this scenario. And now we want to come to the API itself. I will give you a sneak preview to that, or an overview to that, what the API is able to provide you on functionality. Green bolded here, that's what we will have a look shortly. So that means we are running through the how to connect to such a thing and what data points will be used. And I will also explain that terms which we are using here, data points, should not be mixed up with KNX concepts, which we already know. For example, a data point is not the same what we are currently call a group object. A group object is a term from KNX, and this is very specific to KNX, and we have to get used with terminology from IoT environment and IoT developers, which have no clue what the group address and the group object, for example, is. Okay, let's go through API resources. So how to authorize on such an endpoint or such an IoT interface. 2 options, depending where we are located. If it is in the internet environment, we have the OAuth 2 authorization code flow. And the OAuth 2 allows you, that's a standardized authorization code flow, to have a possibility to connect to such an interface with standardized technology. For the basic authentication in the local environment where we do not have DNS services, normally not having DNS services, not impossible, but normally not have it. So here we have the possibility to simply have a username and password to log into such a device. Okay. Other things is having a data point, where the data point, here I remind you, it's an IoT terminology. It's not a terminology chosen from KNX to address developer from an IoT environment. And here behind the data points, we have the possibility to having a format well known to such developers, having collections where you can feed the response when you are somebody asking the data points, give me a list of all data points. We have access attributes defined, and we have also relations where such a data point, which in KNX Classic is a group address finally, in the current situation, is related to some functions. So that means, is a group address somehow embedded in a function? Yes, no. And if this is the case, give me back that I have the possibility to navigate through the API by simply clicking or following the links, let me call it in such a way. Okay. Next, we have functions. The functions is that what we saw in the example from ETS, that the function hosts several, let me call it data points. And here, for example, I have the possibility over a specific function ID to get all data points, or I'm getting all functions within an installation. And as usually, we have here type information. We have the relations, what we said, okay, where these functions are embedded in, possibly in a location. Do they have a specific format? That's a response format. And here we have the information about, is it the collection to have how many functions are embedded in this structure, yes or no. From which offset to which item I'm currently collecting the items and how many are in that collection, let me call it in such a way. Good. Next thing is also that we have the possibility to subscribe to such a thing. So that means if somebody wants to get noticed or notified about a change in the installation, it is possible to say, okay, I want to be subscribed to that or that or that. And I need also a secure connection to that. And for sure here, you have the possibility to say, give me an information if something was changed. We can perfectly discuss about what all information is part when I get notified, or is it only a notification something has changed and they have to ask the subjects. At the end, it is a trade-off between data, which I will transport due to the notification or data I have to ask afterwards if I'm getting notified about it. That's like push information on your mobile phone. You have a new info, you have a new email. That's a push notification. There are you aware that you have a new email received in your account, but when you want to have the actual data, you have to look in the email directly. That's a trade-off between notification service and amount of data will be transported about that. Sure, we have also the possibilities to discover such an interface. Discovery means tell me how many interfaces in such a domain are available. For this, we are also using standardized things like the well-known core. The well-known is an endpoint which gives you the possibility, first of all, how many devices are in a domain and providing such a thing, and secondly, also having the possibility to get basic information about that, what's the entry point from such an API and which version I'm supporting, since the situation is versions and APIs altering faster than that's in the normal KNX Classic installation it is. That's a habit we have to get used with. So that means an API is also altering in sense of that there are new information, different APIs and so on, and therefore we need also a versioning and then information what versions such an interface is supporting. Good. That was a short overview about the API and its endpoints and how does data will be fed into the API itself. The question at the end is, it's not just only an API and an interface. There are many APIs in the world. The question is it able to make a practical working solution out of that? And we are pretty sure, we are convinced that with the things which we already know from the past, standardization in products, having the tool change, supporting that, making and configuration also with included such devices / API, allowing to export the data, having a source of the information, having the workflow, that we are able to tackle and address this subject, even if it is a complex thing and even if it is a very, very fast changing thing, but I'm pretty sure that we are able to tackle it, and that's all what I want to tell you for the time being. Thank you for your participation at that meeting. Many thanks for that. I'm closing that meeting for that for the time being and looking forward. Behave well.